Hey everyone, and welcome. Today we are going to break down the Raft consensus algorithm. Now, the whole point of Raft was to be understandable, and by the end of this, you'll see exactly why. I mean, it was a total game changer, and we're going to see exactly how it works piece by piece.
So we're actually going to walk through the original presentation that introduced Raft to the world. Think of this as our own guided tour. We're going to explore the concepts just as they were first presented, breaking down each idea slide by slide so we can really get to the core of its design.
So here's our game plan. First, we'll tackle the big question. What even is consensus? Then we'll introduce the two core concepts of Raft, the leader and the log. After that, we'll see Raft in action. And then, this is the important part. We'll look at what happens when leaders fail and how Raft provides its famous safety guarantees.
All right, so first things first. What problem is Raft even trying to solve? It solves the problem of consensus. Imagine trying to get a group of people to agree on one single plan, but some of them might not get the message, or they could just suddenly leave the room. How do you make sure that the group makes one and only one final decision? Well, that, in a nutshell, is what consensus is all about for computers.
This slide right here, this shows the ultimate goal. It's called a replicated log. You have a bunch of servers, and each one keeps its own copy of a log. Now, when a client sends a command, the system's one job is to make absolutely sure that every single server adds that command to its log in the exact same order. This lets us build one big, reliable system out of a bunch of potentially unreliable parts.
Okay, so why do we care so much about this perfectly replicated log? Because it lets us build something called a replicated state machine. It's a simple idea, really. If every server starts from the exact same place and they all run the exact same commands in the exact same order, they are guaranteed to end up in the exact same final state. This is the bedrock principle for building truly fault-tolerant systems.
All right, but getting this perfect replication, well, it's famously, notoriously hard to do. So how does Raft make it manageable? It introduces this really powerful, simplifying idea that was a huge departure from older algorithms. And that idea is the concept of a single, undisputed leader.
You see, instead of this crazy, complex web where every server is trying to talk to every other server, Raft just elects one of them to be the leader, and that leader manages everything. This is a brilliant move because it breaks the massive problem of consensus into two much smaller, much easier problems: what to do during normal operation with a leader and what to do when you need to change leaders.
So to handle these leader changes, Raft has this concept called terms. You can think of a term like a political term of office. Each term kicks off with an election. If a leader wins, it gets to serve for the rest of that term. And that term number, it's absolutely crucial. It basically acts as a logical clock, so servers can instantly know if a message is coming from an old, outdated leader.
And all of this comes together in the log. You can see it here. The log is just a numbered sequence of entries. Each entry has two things: the client's command and, this is key, the term number of the leader that received it. But here's the catch. An entry isn't considered done, or committed as they say, until it's been safely copied over to a majority of the servers.
Okay, so now we have the key pieces of the puzzle: a leader, these terms, and the log. Let's see what happens on a good day, the happy path, when everything is working just right.
So here's how it plays out step by step. First, a client sends a command and the leader just adds it to its own log. Second, it sends out an append entries message to all the other servers, which we call followers. Third, the followers get the message, add the entry to their logs, and send back a little got it acknowledgement. Fourth, and this is the magic moment, as soon as the leader hears back from a majority of the followers, it knows the entry is safe, and it commits it. Finally, it just lets all the followers know that, hey, this entry is officially committed.
So, how does Raft make sure that these logs never, ever get out of sync? It uses this simple but incredibly powerful consistency check. See, whenever the leader sends a new entry, it also includes a little piece of information: the index and term of the entry that came right before it. A follower will only accept the new entry if its own log perfectly matches at that previous spot. If there's any kind of mismatch, it just says nope and rejects the request. This simple rule guarantees that the logs can never split apart.
Okay, so that all works beautifully when the leader's up and running. But look, the whole point of this is to build a system that doesn't break. It's supposed to be fault-tolerant. So we have to ask the most important question: what happens when that single point of authority, the leader, crashes or just disappears? Well, the answer is the election mechanism that's built right into Raft. You see, a system with a single leader is only as good as its ability to replace that leader when it fails, so let's see exactly how that works. Okay, so every server can be one of three things. Most of the time, they're followers, just passively getting updates from the leader. But if a follower goes for a certain amount of time, it's called an election timeout, without hearing a peep from the leader, it starts to get suspicious. It assumes the leader has failed. At that point, it switches its state to candidate and kicks off a brand new election. And if it wins, it becomes the new leader.
And the election itself is actually pretty simple. So a follower's little timer goes off. The first thing it does is increments the term number, kind of starting a new era. Then it changes its state to candidate. It immediately votes for itself, and then it fires off request vote messages to all the other servers. If it manages to get votes from a majority of the servers, boom, congratulations, it's the new leader for this term.
Now, this whole election dance has two big goals. First up is safety. You absolutely can't not have two leaders in the same term. Raft guarantees this with a simple rule. Each server can only vote once per term. Easy. The second goal is liveness. An election has to actually pick a winner eventually. Raft achieves this with a really neat trick, randomized election timeouts. By giving each server a slightly different waiting period, it makes it super unlikely that two of them will start an election at the exact same time and split the vote.
Okay, so we have a new leader. Congrats! What's its first order of business? Well, it's gotta clean house. Its first job is to fix any inconsistencies it might find in the follower's logs. It does this by finding the last log entry where its log and a follower's log agree. And from that point forward, it just forces the follower's log to match its own, deleting any entries that conflict and adding any that are missing. The leader's log is always the source of truth.
We've seen how Raft works on a good day and how it recovers from failure. But the real magic of a consensus algorithm isn't just that it works, it's that we can prove that it works correctly under all kinds of crazy conditions. And that brings us to the final, and maybe most important part, Raft's safety guarantees.
So this right here, this is the one rule that can never ever be broken in any consensus system. It's the fundamental promise. Once a decision has been made and applied, that's it. It's final. It can never be undone. It can never be contradicted. Everything else we're about to talk about is all in service of upholding this single critical rule.
And how does Raft pull this off? Well, it all comes down to this one beautiful property. It says that once an entry is committed by a leader in one term, that exact same entry is guaranteed to exist in the log of any server that gets elected leader in any future term. This is what prevents a new leader from accidentally overriding a decision that was already made.
Okay, that's a big promise. How does Raft actually enforce it? With the simple but powerful restriction on voting. When a candidate server asks for a vote, it also sends along some info about how up-to-date its own log is. And another server will deny that vote if its own log is more up-to-date than the candidate's. This ensures that no server can even become a leader unless it already has all the committed entries from past terms. It's a brilliant way to make sure no data ever gets lost.
Now this next part is a little subtle, but it's super important for plugging a really tricky potential loophole. A new leader can't just assume that it can commit old entries left over from a previous leader's term. To be 100% sure those old entries are safe, the new leader has to first successfully commit a new entry from its own current term. That action basically proves it has majority support, and only then is it safe to go back and commit the older entries.
So, there you have it. We've just walked through the heart of the Raft algorithm. An algorithm that's famous not just because it works, but because it was specifically designed so people could understand it. We saw how it breaks down this huge, complex problem into smaller pieces like leaders, logs, and elections. So I'll just leave you with this question to think about. What do you think are the key ingredients that make a truly complex system, like this one, genuinely easy to grasp?